A load calculation is an assessment of the electrical power requirements of a building or system. It involves determining the total wattage needed for all electrical devices, appliances, lighting, and heating or cooling systems. A standard load calculation is a simplified method that uses fixed values for average power consumption based on the type of building and its size. It provides a general estimate of electrical demand. An optional load calculation is a more detailed method that considers the actual electrical usage patterns and specific equipment installed in a building. It provides a more accurate estimate of electrical demand. To pass the test for load calculation, it is important to understand the principles of electrical load calculation. This includes the concepts of power, voltage, current, and resistance. Know the different methods of load calculation. Be familiar with both the standard and optional methods. Be able to apply the appropriate method. Determine which method is most suitable for the specific test situation. Practice and study. The more you practice load calculations, the more confident you will be in the exam. Now, let's delve deeper into the principles and methods, starting with the fundamentals. Understanding power, voltage, current, and resistance is crucial. Power, measured in watts, represents the rate at which electrical energy is transferred. Voltage, measured in volts, is the electrical potential difference that drives current through a circuit. Current, measured in amps, is the flow of electrical charge. Resistance, measured in ohms, opposes the flow of current. These four quantities are related by Ohm's law, which states that voltage equals current times resistance, expressed as volts equals amps times ohms. Power can also be calculated as voltage times current, or watts equals volts times amps. Understanding these relationships is fundamental to calculating electrical loads. When performing a standard load calculation, you'll typically use predetermined values based on the type and size of the building. For example, the National Electrical Code, or NEC, provides tables and guidelines for calculating general lighting loads based on the square footage of the building. You might also use fixed values for appliance loads, such as dishwashers, refrigerators, and washing machines. The standard method is generally quicker and easier to apply, but it provides a less precise estimate of the actual electrical demand. The optional load calculation method, on the other hand, takes into account the specific electrical equipment and usage patterns of the building. This method requires a more detailed inventory of all electrical loads, including lighting, appliances, heating, cooling, and other equipment. You'll need to determine the actual power consumption of each load and factor in any diversity or demand factors that may apply. Diversity factors account for the fact that not all electrical loads will be operating at their maximum power consumption simultaneously. For example, a residential dwelling may have multiple lighting circuits, but it's unlikely that all of the lights will be on at the same time. Demand factors are similar to diversity factors, but they are typically applied to larger loads, such as heating and cooling systems. The NEC provides tables and guidelines for applying demand factors to various types of loads. When choosing between the standard and optional load calculation methods, consider the specific requirements of the test and the information available to you. If the test provides detailed information about the electrical equipment and usage patterns of the building, the optional method may be more appropriate. However, if the test only provides general information, the standard method may be the better choice. To prepare for the load calculation test, practice solving a variety of problems using both the standard and optional methods. Pay close attention to the details of each problem and make sure you understand the assumptions and limitations of each method. Review the NEC tables and guidelines for calculating electrical loads and applying demand factors. It's also helpful to work through practice problems with a qualified electrician or instructor who can provide feedback and guidance. Now, let's discuss some specific examples of load calculations. Firstly, consider a residential dwelling with a floor area of 1,500 square feet. Using the standard load calculation method, you would first determine the general lighting load based on the square footage. According to the NEC, the general lighting load for a dwelling unit is typically 3 watts per square foot. Therefore, the general lighting load for this dwelling would be 1,500 square feet times 3 watts per square foot, which equals 4,500 watts. Secondly, you would add any additional appliance loads, such as a dishwasher, refrigerator, and washing machine. The NEC provides fixed values for these appliances, typically ranging from 1200 watts to 1500 watts per appliance. Assuming the dwelling has a dishwasher, refrigerator, and washing machine, the total appliance load would be approximately 4000 watts. Thirdly, you would add the heating and cooling loads. The NEC provides guidelines for calculating heating and cooling loads based on the size and type of equipment. For example, a central air conditioner may have a load of 3000 watts, while an electric furnace may have a load of 5000 watts. Fourthly, after adding all of the individual loads together, you would apply any applicable demand factors. For example, the NEC allows a demand factor of 35% to be applied to the portion of the general lighting load exceeding 3000 watts. In this case, the demand factor would be applied to 1500 watts, resulting in a reduced load of 525 watts. Fifthly, the final step would be to add the reduced load to the other loads to determine the total calculated load for the dwelling. Now, let's consider an example using the optional load calculation method. Firstly, you would start by creating a detailed inventory of all electrical loads in the building. This would include lighting, appliances, heating, cooling, and other equipment. Secondly, for each load, you would determine the actual power consumption in watts. This information can typically be found in the equipment's nameplate or in the manufacturer's specifications. Thirdly, you would then factor in any diversity or demand factors that may apply. For example, you might apply a diversity factor of 50% to the lighting load if you know that only half of the lights will be on at the same time. Fourthly, you would add up all of the individual loads, taking into account any diversity or demand factors to determine the total calculated load for the building. Remember that the optional method requires more detailed information and can be more time-consuming than the standard method, but it provides a more accurate estimate of the actual electrical demand. Also, consider a commercial building with a large number of computers and electronic equipment. The standard load calculation method may not be appropriate for this type of building because it does not take into account the specific power requirements of the electronic equipment. In this case, the optional load calculation method would be more suitable. You would need to determine the power consumption of each computer, monitor, printer, and other electronic device and factor in any diversity or demand factors that may apply. By using the optional method, you can more accurately estimate the electrical demand of the building and ensure that the electrical system is properly sized. In addition to the standard and optional methods, there are other specialized load calculation methods that may be used in certain situations. For example, the NEC provides a method for calculating the load for electric vehicle charging equipment. This method takes into account the charging rate of the equipment and the number of vehicles that will be charged simultaneously. There are also specialized methods for calculating the load for data centers, hospitals, and other facilities with unique electrical requirements. By understanding the different load calculation methods and their applications, you can be better prepared to pass the test and design safe and efficient electrical systems. Remember to consult the latest edition of the NEC and any applicable local codes and regulations for specific requirements. Also, consider consulting with a qualified electrician or electrical engineer for guidance on complex load calculation problems. A strong understanding of electrical theory, the NEC, and practical experience are key to success in the field of electrical load calculations. Keep practicing, studying, and seeking out opportunities to expand your knowledge and skills.